welcome. We're going to be going through the notes for an introduction to volume here. So let's take a look at some of these shapes and how to calculate their volumes. The first one, we have this picture here, and this would be a rectangular prism. A rectangular prism has two opposite faces or bases that are congruent with a height in between them. In other words, we have this like top face and this bottom face, and we can calculate those with finding the area 4 by 3 and then multiplying by 12. But we have, with rectangular prisms, we're not sure which ones are the opposite congruent faces. All right, so now for the calculation, it is fine to use just a shortcut calculator. So if I say rectangular prism calculator, it just says that the volume is length times width times height. And my length was 4, my width was 3, and my height was 10. And then all I need to do is screenshot this piece here. I don't even have to screenshot the whole picture and everything. And we'll make sure it's going to clipboard, capture, paste it in. All right. A triangular prism has two opposite faces that are congruent with a height in between them. The area of the base is the area of a triangle. What does that mean? We're going to find the area of this triangle and then multiply it by the height, which is 11. So now let's try, instead of a rectangular prism, let's try a triangular prism calculator. And it gives us some information here. We're going to do this a little bit different because this has these 3 edges and it does it through a much harder type of calculation. So let's say that we want to do like a right triangular. Oops. There we go, a right triangular prism calculator. One of the ones we can do is calculator soup. So if we do, not this version, but here we go. So if we have the triangle base and the triangle height, capital H, so that would be like 3 for that height and 5 for that base. So the height is 3 and the base is 5 for the triangle, but then the height for the prism part, H, is 11. It's that line connecting the two of them. So when I put that in there and I say calculate, whoops, this should have been a 5. There we go. And then it gives me that much there. So I can screenshot this, capture, put it in, then we're going to keep on repeating. Now this one's a little bit different. It has a little bit of combination going on. So I'm going to go into the drawing and try to think about this as 2 pieces put together. So we have a rectangular prism or a box on the bottom. Then we have a triangular prism here on top. It says this full height is high, but this height is 2, which means that if I copy and paste this number, that 3 would be like the height here. So that height's going to be a 3. And that's good to think about. So now I have a triangle that's like 3 by 4, and its height is 9. So I can use this triangular prism again because it has a 3 by 4 with a height of 9. And that calculation is, for the triangle, 54. That's for the triangle piece. But then for the rectangular prism calculator. We want the length times width times height, and in this case that's going to be 2, 4, and 9. So the length is the 4, the width is 2, and the height is 9, you could say. That's going to give me 72. So I'll press enter to go below that picture. So I have 72 and 54. Then I would have to say 72 plus 54, and I can add those two things together. That'd be 126. You can use a calculator to work that out, but that is how we would calculate that, is just break it into separate pieces. And for other prisms, we would say two opposite faces or bases are congruent with a height in between them. We're going to cut the opposite bases into shapes you can calculate. The area into which you can calculate the area, like a rectangle, triangle, or circle. And when we say circle, we mean like circle or half circle or any kind of circle. So that's just kind of keeping us on track with recognize that you can take a shape that maybe looks like a house and you can cut it up into triangular prisms and rectangular prisms and put them back together. Okay, cylinders. Cylinders are very straightforward, very much like the other shapes that we were looking at. The slight difference this time is that on a cylinder, the base area that we're looking at is a circle. And we can, again, use a shortcut calculator like volume of a cylinder. And all it wants from us is the radius and the height. Well, that's interesting, because my height is like this distance between the circles, the 20. And right here it has a line going all the way across, which is 6, but the radius only goes part way across, if you notice that. So it's not 6, it'd be 3. The height is still 20, that distance between the two bases. And now it gives me a solution, a calculation for that. So I'm going to copy and paste that into these notes here. And it gives me an approximate value. It's approximate because of that pi, which is an approximate number. A cone is very much like a cylinder, except it converges to a point. So the base is a circle, and it converges to a point. The volume formula for a cone is, it's going to be pi r squared times h, but then we have to divide by 3. We take a 1/3 on there. You don't necessarily have to know that, but it is helpful to know. So right here, pi r squared times h, and then divided by 3. So we need the radius, and we need the height. We don't need this diagonal line, which is called like the lateral edge there. So we need the radius. Now I see that it's 6 across, which means my radius again is going to be 3, and my height is going to be 8. So the radius is 3, the height is 8. That gives me this calculation right here. I'll copy and paste it, put it in here. A pyramid is very similar to a cone in that you're finding the area like you would where you do like its sister shape. So in this case, it's related to a rectangular prism. So it's going to have a length times width times height. But because it comes to a point, the volume formula for a rectangular pyramid is length times width times height divided by 3. So now we have this calculation. Let's do rectangular pyramid calculator. And again, it just has that length times width times height. So my length times width times height is 3 times 4 times 5. The height is 3. The width was 4, and this was 5. And that gives me a total of 20, a calculated value of 20. And then this last one I'm looking at for triangular pyramids. The base is a triangle. It converges to a point. And the volume formula for a triangular pyramid, let's see if we can scroll down, is going to be, oh, I'm getting a little bit of glitch there. It's going to be length times width times height. But we're going to divide the length and width for the area of a triangle, and then times 3. Oh, that's different. There we go. Oh, looks like it's getting a little hung up there. So for the calculation, I'm just going to say volume equals 2 times 6 divided by 2. So 2 times 6 divided by 2. That gives us the triangle. But then we're going to multiply that by 4 and then divide all of that by 3. So let's just type that into a calculator. And that gives us 8. In general, what you're going to see here is that it's the area of the base. So in this case, that'd be 3 times 4, then times the height. The base on a triangular prism, those faces are triangles. So that's why it's that bottom area, which in this case was 7.5. And then you multiply that by the height, that distance between those two faces. If it's got more than one kind of shape put together, a composite prism, you could say, you're going to do each volume and then put them together. If it's a cylinder, the area of that base is that pi r squared, and then we multiply by the height. Down here, we have the area of the base, and is different because once we're looking at cones and pyramids, we have to also divide by 3. That times 1/3 is part of the formula. There we go. That's the end of these notes for 9A. Next, take a look at 9B.